Good day, everyone. Thanks for listening in. Welcome to Stantec's Global Thought Leadership Series on data centers. This is episode 1. In this episode, we'll be talking about data center water sources and cooling. Today, our conversation will be with Stantec's data center experts from our UK, Australia, and North America teams. My name is John Major, and I'm the Mission Critical Sector Leader at Stantec. I'll be your host and moderator for this episode. The reason we're talking about water and cooling today is because water and cooling are two of the three essential ingredients of today's data center. The third ingredient is energy, but we'll save that topic for its own episode because there's a lot there to discuss with that one. Data center cooling and water usage are top of mind at Stantec as the performance demands of data centers continue to grow. Cooling is increasingly complex, and as we try to balance the water, energy, and space and noise impacts, we really have a bunch of new questions and problems to solve. Our clients are seeking innovation in the pursuit of their climate resilience and operational efficiency goals. And finally, both of these challenges create interesting questions for us from a design and engineering perspective. So the design innovations that we're seeing around the world and the new ideas that we're exploring in response to these increasing workloads from AI and other high performance data centers, from a water and cooling perspective, they're very exciting topics for our designers and engineers. So today, at a high level, we're going to be discussing how are the mindsets shifting and how is that impacting design. We're also going to be talking about alternative water sources and technologies. And finally, what are some of the new cooling solutions that we're seeing for data centers? I'm hopeful that this episode will include some highlights and insights that you haven't heard elsewhere. So, all right, let's get into it. Henry, the world's getting hotter and drier, and water scarcity is a growing concern around the world. We see this in our communities, we hear the feedback from our communities. So, how does that change the way developers and operators should be thinking about water, and what alternative water sources should they be looking at?
A key concern for us with the water is its benefits for us. So it greatly improves the efficiency, and at the minute we are heavily congested on grids all around the world. We need to make the most out of the power we've got, and the best way to do that is to use water for the cooling process. Unfortunately, water is also fairly scarce, but the improvements in PUE from 1.5 to 1.6 down to 1.2 to 1.3, there's no other way around consuming water for cooling, and we really need to look at how we're going to do this. The things that we really need to consider, though, are climate change as a key topic, because all designs at the minute assume that the water we've got now is the water we will have 10, 15, 20 years in the future. Uh, any design that we've seen or reviewed or looked at in the past doesn't account for the fact we might have a 10, 20, 30% drop in water availability. And it assumes that in a mass drought scenario, the logistics of getting tankers to every data center that requires water is somehow feasible. Whilst on an individual failure at an individual data center, it might be possible. But once you get into central London and you've got dozens of these data centers, all of a sudden having hundreds of water tankers running around the streets of London on top of whatever else is required for the public demand just isn't going to be feasible. And we don't think that's been considered for current and existing designs.
Jack, you're already building data centers in these extreme clients. What are you seeing on your end?
Yeah, thanks, John. Yeah, I think we are seeing a lot of, obviously Australia's been one of the more dry continents. We are already experiencing drought over the last couple of decades. So I guess our communities are expecting there's a bit of a surge in, questions regarding the water used in data centres. So there are some of our key clients which already are looking at dry cooling solutions or looking at air solutions. Yes, I guess what Henry touched on, this does use more power. However, that can be offset, and I guess the upside of being very dry and I guess more sun-soaked continent is you get more opportunities for renewable power through PV, and we have wind solutions. So we are looking at the moment, as you said, these can be offset. The energy demand can be offset with renewable solutions. We're taking limiting the water usage in those avenues. Or the other opportunity is we're looking at recycled water usage through sewer mining, through water treatment plants. So there are options out there. Once again, we're actually adding to more complexity in our data centers by doing the water treatment solutions. So once again, we've got already a complex facility, getting more complex by putting water treatment solutions in there. So you're basically getting recycled water and actually turning it into pure water again, so I can go through cooling towers and the like to make sure you get a high PUE. So that's the challenge. Be complex. It's a balancing act, and those water balances need to be considered. As once again, I think our communities are seeing the households are first and foremost in this demand for water, and data centers come second. So how do we make sure that doesn't become an issue to our clients and our but also our communities. So that's the challenge at the moment, the balancing act, especially the large numbers and size these data centers are moving up to. Like, how do you you probably can't physically tank water to these sites anyway if something did happen. So once again, we're sort of looking at what's the option here, and I think dry cooling is a logical solution. It doesn't increase, I guess, the energy usage, but if you can offset that as we can here with renewable power, that'd be a good opportunity. And we have seen some of the hyperscalers actually invest heavily in solar farms, and to actually offset that. And there's a lot of like hundreds of gigawatts of megawatts of solar power in the country areas of Australia is being transmitted into the grid now to offset that. And with I guess power purchase agreements for renewable powers helping offset that, so they are sustainable from their approach as well. As much as our clients do want to be to the communities and their options they provide.
Thank you, Jack. What about you, Josh? What are you seeing these days?
So, John, across the U.S., the water use does vary quite a bit. However, there has been a general shift towards reducing WUE or reducing water use. Using water on site for some of these data center sites, particularly the hyperscalers, is on a scale unlike a lot of things we've seen. Probably the closest thing that we at Stantec see is a municipal water treatment storage and treatment facility. And that's due to the balance between the demand we can get from the local jurisdiction, the site, and the demand that the mechanical equipment requires. And so that imbalance will result in large on-site storage. The thing with large on-site storage is then that drives the need for a chemical treatment system, and that itself is very large. And so now we're talking about bleach and acid requirements for the site at again on a very large scale. Also, these systems will drive the need for a whole another layer of infrastructure that has to be coordinated amongst the other on-site utilities such as fiber and power and the other mechanical piping systems. And so there are obviously regulatory requirements and safety that go along with all this. That is just another layer to the complexity of these on-site space that we have available to us. So it's kind of all things to consider when we're looking at large scale evaporative system on the mechanical side.
And Jack, what are some of are those challenges the same in Australia in terms of treatment?
Yes, they are. So there's still a high requirement of the water that being used in the cooling system to be, if it's not reticulated or recirculated within the system, that is in an open cell cooling tower, for example, it has to be treated to a high level. It has to be a pure water that comes in and then treated as well. So it is a very complex arrangement. And as I guess Josh had said, it actually has more complexity, more treatment, more things you need to consider on your site. Through that. So yeah, we are seeing that. I think there would be an opportunity to scale these, to look at this as trying to reduce that, but once we are still seeing the regulations requiring this water to be highly, I guess, refined and industrially treated to put this back into our cooling systems.
Yeah. Well, what alternative water sources are in your frame?
So we are seeing like there is the wastewater, you can use stormwater, but once again, this requires to consider the water balance. So you only can utilise the water you have. So if you're looking at soil mining, you still need a fairly large supply for that to actually bring that into your system and utilise that. And at the moment, that's once again, so you've got to have a water balance. So if you're using soil water, for example, to mine it and treat it and actually use in your system, you need to come from a big I guess, inflow of sewer. So you need to be in a highly metropolitan area to do that, to actually bring in that water and utilise that. But you can't take it all because they still need some fluids to work down the sewer. So you've got to get that trade off, and that's where our local water teams actually can support us in actually getting that water balance right, looking at the networks and actually how they can work with the authorities and actually work at how they can get that balance right. Because that's once again, we're just adding more complexity to a very complex solution. I guess facility already, but that's I guess the challenge our engineers enjoy to do, working through that.
Yeah, wonderful. Henry, what innovations are you exploring in the UK?
So here in the UK, we've been looking at various things. Again, treated wastewater, but as was mentioned there, you've got to have the sufficient volume for that. The other solutions are looking to use reverse osmosis to treat seawater if you're near the coast. Some other options as well is mine water. Mines contain vast, tens of millions of litres of water. And they, so for instance, the one in Stoke, the coal mines down there, they used to pump 4.5 million litres a day out to keep that dry. And it's currently full. So if you could site a data center somewhere in the vicinity of those mines, you essentially have an unlimited water source that no one is using because it's nearly a mile, 800 meters, I want to say at the depth, deepest underground. So there are sources of water out there, especially in the UK, where we've got lots of ex-mining facilities that have just filled up over time and would prove fairly renewable in terms of the sheer volume of it. Other things you can obviously look at is instead of obviously consuming the water, using river water and a heat exchanger. So using our water team here in the UK, engaging with the Environment Agency and seeing what we can do. So can we raise the river water by a degree and a half? What additional or free cooling does that provide us? Massively improving the PUE, having zero impact on the environment, but using water without actually consuming it and discharging it to atmosphere. The other thing we can look at as well here in the UK, we're getting a lot of bad press about our water usage. The huge stores and volumes of water we've got on site and that have been allowed through public or private networks, whether we should leave ourselves the ability to support the public networks. So designing for load shedding of 10, 20, 30% of our water consumption in peak drought periods and offering that back to the public network when it needs it most. That way we can change the story on water from us draining from the local communities to us providing for them when they require it and we have the ability to give it.
Wow, wonderful. Well, let's pivot. Let's talk about the cooling technology itself and the new design approaches that we're seeing. So when we're designing for these larger workloads such as AI, what new solutions are being considered? Jack, why don't you take the first crack at it?
Yeah, so we do have some sites here now that are looking at full air-cooled solutions. So whether it's an air-cooled chiller, dry coolers, that is something we are looking at. There is, but that again takes more plants, more energy. But once again, we need bigger sites. And I think the challenge with, as we're talking about, as we're moving up into the size of these data subs into hundreds of megawatts and up to gigawatt and the like, the air-cooled solutions though do have an impact on the acoustic challenges with those. So these sites need to be situated in a considering the communities they sit in, or lack of, not in communities in industrial areas, so that acoustic impact doesn't affect those areas. Because when you get like a 400 megawatt site, you might be the closest that could be near to a residential receiver about a kilometre. So you're sort of looking at these data centres need to be located on fairly big sites. At least a fairly long way away from the nearest, receiver, residential property. So they're the things you need to consider if you're pivoting to an air-cooled solution, which have been around for a long time. But obviously, once again, we're talking at a next level scale of 100 megawatts of plus of cooling. So we actually need to look at how these things cool and the air, and the air pollution noise pollution they can generate in those communities. So considering that as part of your mix and your design and your layouts.
Yeah, Josh, it's when we think about North America, there's so much activity and so much variety in data center topologies. What are you seeing in the way of cooling solutions? What's new? What's changing? What can we predict about the future? What are you seeing?
Yeah, John, you're right. It's an ever-changing industry for sure. I think that's an understatement. But a couple things come to mind. So first, we're starting to see hybrid mechanical plant systems, and these are systems which use the water when it's needed, when it's available, and then can revert back to all electric if that's available. One example of this would be a water-cooled chiller connected to either like a dry cooler type device or a fluid cooler that's got evaporative wetted media. And so the systems that we can design can be designed purpose built for either one of those, or we could design a hybrid solution where the facilities team can operate that system in a variety of modes, depending on what's most efficient from a power and water standpoint. This also allows them to future-proof their facility. So even though right now, yeah, we have water, we have power, in the future maybe they don't have water, or maybe power becomes a concern. So I think this is an area that needs more focus, but we're starting to see it being implemented right now. The other thing is direct-to-chip cooling or liquid cooling. And what this does is it allows us to operate the mechanical system at a higher temperature on average because we're delivering that fluid directly to the chip instead of delivering it to an airside mechanical system that's then cooling the chip with air. And so by doing that is effectively raising our mechanical system temperatures. It's allowing us to use more economizing hours, and it's going to allow us to reduce the total energy use on average, and then also reduce the amount of water that we're using on site, which is smaller tanks, less chemical treatment, all the other things that I mentioned previously.
One of the things that's really interesting about this to me is that, and especially in North America, we have really two major data center form factors. We have the traditional air-cooled data center where we're blowing air across the servers. But as the rack densities get higher and higher, the air can no longer cool those servers, so we move to the direct-to-chip cooling solutions. And you might think that the industry is going to gravitate, everybody's going to go direct to chip. But it turns out that both data centers have their use case, and we're seeing equal demand for each type of data center. So it seems to me that we'll continue to see innovations within air-cooled data centers at the same time we see those innovations in the liquid cooling for the data centers. Do you have any thoughts on that, panel?
So from the UK side of it, we're still going to have low density, I think, for quite a while. We're relatively very expensive in terms of electricity over here. And so higher density deployments we're not seeing as much. We are hoping to, obviously, in the future, and that's the point of AI growth zones and things like that. But as discussed, all types of deployment can be made more efficient, whether it's low or high density. We've got a much more temperate climate over here in the UK, and so we can do things with system selection, as simple as that. So taking the same hybrid units, the same model, the same scale, and changing the capacity of them, so from 1800 down to 1600 or 1400, not only does it extend the range of free cooling that you'll get, so lowers your peak PUE, lowers your power consumption, but it also reduces your annual water consumption by as much as 15-20%, depending on where you are in the UK. And it, like I said, increases the temperature that your free cooling will kick in to. So you get a lower PUE, therefore more IT computer out of it. You get lower water consumption out of it. And all it takes is adding some additional units in. So an additional 10% of your units, you get more compute out of it. You get more water, you get lower water consumption out of it. And all you need to do is find the space somewhere, which as much as the hybrid units and any sort of water or free cooling units are larger, if you've already found space for the capacity you're looking at, finding space for a few more really can make all the difference. Like I said earlier as well, alternative water sources here in the UK, we've got quite a few, and you don't necessarily have to go all one single solution. We are massively out of power at the minute, waiting decades for a connection to the grid. So we're going to have to make the most out of what we've got. And so using the water in terms of putting it through a plate heat exchanger first, raising the water temperature before you then put it onto an evaporative, doing things like that, getting dual use out of your water is going to have to be something we're going to have to consider. Is how much use can we get out of every single liter of water, and if we can't discharge that to atmosphere, do we just put it through the plate heat exchanger and put it back to wherever that water source is? If it's underground, if it's in a river, make the most of everything that we currently have at our disposal.
Yeah, thank you, Henry. Well, it's clear that both water and cooling are front and center in data center design and performance and efficiency, and will be for the next several years. And so I want to thank the panelists for their insights for where the industry is heading. And I want to thank the audience. Thank you for listening in. And for more insights like this, follow Stantec on LinkedIn and connect with us individually to keep the conversation going. Thanks, everyone.